In this question, it is given that consider the lines L1 and L2 given by this equation and this equation. A line L3 having direction ratio 1 minus 1 minus 2 intersects L1 and L2 at points P and Q respectively. Then the length of the line segment PQ is, you have to find the correct choice. First, I am going to do this question by normal way. Then I will do this question by one more way. The other way will be slightly shorter than the first way, but second way I will be telling you to make your concepts strong, and because the concept I will be using in the second way, that concept is very good, and at many places that concept can make the question too much easier. Here that concept is making the solution slightly shorter, but at many other places that can make the solution very short also. But first let me do this question by normal way. To do this question by normal way, you know that first I would like to find the corner of the point P and Q. For that, let it be equal to lambda, let it be equal to mu. Whatever is the value of lambda, the point 2 lambda plus 1, lambda plus 3 and 2 lambda plus 2 will surely lie on this line for every value of lambda, and whatever is the value of mu, the point mu plus 2, 2 mu plus 2 and 3 mu plus 3, this point will surely lie on this line for every value of mu. Suppose these are the coordinates of the point P. Similarly, these are the coordinates of the point Q. Therefore, direction ratio of the line PQ will be 2 lambda plus 1 minus mu plus 2, lambda plus 3 minus 2 mu plus 2, 2 lambda plus 2 minus 3 mu plus 3. That is, I will be getting 2 lambda minus mu minus 1, lambda minus 2 mu plus 1, 2 lambda minus 3 mu minus 1. Because L3 is passing through P and Q and L3 has direction ratio 1 minus 2, hence I can say direction ratio of PQ are also 1 minus 2. Hence I can say 2 lambda minus mu minus 1 upon 1 is equal to lambda minus 2 mu plus 1 upon minus 1 equal to 2 lambda minus 3 mu minus 1 upon minus 2. If I equate these two, I will be getting minus 2 lambda plus mu plus 1 is equal to lambda minus 2 mu plus 1. This implies that 3 lambda minus 3 mu equal to 0. That is, I can say lambda minus mu equal to 0. And if I equate these two, I'll be getting 2 lambda 4 mu plus 2 is equal to 2 lambda minus 3 mu minus 1. Note that I have ignored negative sign in both of them. That is, I can say mu equal to 3. Hence from here I get lambda is also equal to 3. Hence from here I can say the point P will have coordinate 7, 6 and 8. The point Q will have coordinate 5, 8, 12. And now the distance PQ can be calculated very easily. This is 2 square plus minus 2 square plus minus 4 square. That is 2 under root 1 plus 1 plus 4. That is 2 under root 6. Hence I can say first choice is the correct choice. Now I am going to do this question by alternative way. Otherwise the procedure is going to be same. Only one thing which I will be using in this question will make the solution slightly shorter, but as I told you, that concept is very good. That concept can make the solutions very short while doing some other question. Note that we have to find the length of the line segment PQ. Isn't it solution will become shorter if I shift the axis to the point either 2 to 3, that is this point, or at the point 1, 3, 2, because by shifting of axis the length of line segment is not going to change, but because in this corners are slightly bigger, I would like to shift the origin to this point. Obviously for getting the equations of two lines in shifted form will be obtained by writing x plus 2 for x and y plus 2 for y and z plus 3 for z. That is, I'll be getting x plus 1 by 2, y minus 1 by 1, z plus 1 by 2. Actually, I must have written capital X, capital Y and capital Z, but makes no problem because finally we have to find the length PQ only. And this second line will become very easy. It will become x upon 1, y upon 2, z upon 3. The benefit of this way is, suppose by chance in the question examiner gives root 3 here, root 2 here, or root 2 plus 5, means he gives the coordinate in difficult form. By taking this concept of shifting of origin, in that case the course solution will become very simple. And now proceeding as usual, let it be equal to lambda, let it be equal to mu. Hence any point on this line can be written as 2 lambda minus 1, lambda plus 1 and 2 lambda minus 1. Any point on this line is mu, 2 mu and 3 mu. Suppose these are the coordinates of the point P and these are the coordinates of the point Q. Hence direction ratio of PQ will be 2 lambda minus 1 minus mu, lambda plus 1 minus 2 mu, 2 lambda minus 1 minus 3 mu. And direction ratio of PQ are 1 minus 1 minus 2 are also there. Therefore this upon 1, this upon minus 1, this upon minus 2. That is, I will be getting minus 2 lambda plus 1 plus mu equal to lambda plus 1 minus 2 mu. And equating these two, I get 2 lambda plus 2 minus 4 mu is equal to 2 lambda minus 1 minus 3 mu. That is, I get 3 lambda minus 3 mu equal to 0, and this means mu equal to 3. Hence I can say lambda is also equal to 3, and therefore the point P becomes 5, 4 and 5, and the point Q becomes 3, 6, 9, and therefore the length PQ becomes 2 square plus 2 square plus 4 square, that is 2 root 1 plus 1 plus 4, that is 2 root 6. Hence I can say first choice is the correct choice.